This is a heat and temperature change problem. We're given a delta T, or means to calculate delta T, and we're asked to calculate how much heat is involved. The equation is that our heat is equal to mass times our specific heat capacity times delta T. So we will need the specific heat capacity of iron, and more specifically, we'll need the heat capacity of iron given in calories, which is this value here. And remember that these values will be given on quizzes and exams. Okay, no need to memorize. All right, now we have our value for the specific heat capacity. We can substitute in and calculate our heat value. Our mass is 9.00 grams of iron. Our specific heat capacity is 0.1078. Units are calories per gram degree C. And our delta T value is going to be determined by TF minus TI. So we have our final temperature is 119.2 degrees C, and from that we're going to subtract 19.2 degrees C. So our delta T is 100.0 degrees C. A word of warning, remember to use the sig-fig rules for addition and subtraction. These rules are based on decimal places, not counting sig figs. So here we are good to the tenths. Here we're good to the tenths. So our result should be expressed including the tenths decimal place. And that means this value for delta T is going to have 4 sig figs associated with it. So we'll plug in our value. Now, before we do our calculation, we can check our sig fig, or check our units. We see grams cancel, degrees C cancel, and the only unit that survives is calories, which is what we want. That's what we've asked for, so that's good. We can chunk out our calculator value, which comes out to be 97.02 calories. Now go back and figure out our sig figs. We would see 3 sig figs here, 4. As we mentioned before, this has 4 sig figs. So our least number of sig figs is 3 because this is multiplication. We go back to multiplication division rules. We want 3 sig figs, which means our calculator answer needs to be rounded to 3 sig figs. We're going to drop the 2 and round down. Our final answer is 97.0 calories.